AP Calculus AB, we're going to be looking at a table of values and seeing which theorems we can apply to answering these questions. The rate at which water flows out of a pipe in gallons per hour is given by a differentiable function r of time t. The table below shows the rate as measured every 3 hours for a 24-hour period. So here's what we know. If a function differentiable, it's also continuous. And that tells us that any theorem that we've learned has to apply to this. Estimate the value of r prime of 5, indicating correct units of measure. Well, r prime of 5 is going to fit in here someplace between 3 and the 6. So it would make sense to me to do this approximation. We are going to approximate it with the average rate of change of some x values that are close to 5, such as 3 and 6. R of 3 is 10.4. R of 6 is 10.8. 3 minus 6 is negative 3. This is going to give us negative 0.4 over negative 3. You can leave it like that. This is 0.133. We should label this. The original function is gallons per hour. So that means this would be gallons per hour per hour. If r is measuring in gallons per hour, then r prime, this is gallons per hour, and this is per hour, so it's gallons per hour per hour. Explain what this means about the value of r of t. I don't really understand that question. I wonder if I mistyped this. Like if it said, what does r prime of 5 mean? Well, I would understand what that means. I guess what we could say as it relates to r is that the r value is increasing because it's positive. It's a pretty open-ended question. Explain what this means. You would be asked something much more specific on an AP Calculus test. But we could say that the rate at which the water is flowing out of the pipe is increasing. That would be a good thing we could say. You should probably write that down. Using correct units of measure, what's the average rate of change of r of t from 3 to 18? So far we haven't had to use any theorems. The average rate of change is going to be r of 3 minus r of 18. You could write those in either order, but these below have to be in the same order. Using the table, that's going to be 10.4 minus 10.7 over negative 15. That's negative 0.3 over negative 15. The faster I want to write, the worse it is, and then the longer it takes. So the average rate of change is 0.02. Using correct units, the top units, it says, is gallons per hour, and the bottom would be in hours. So this would be gallons per hour, or you could say gallons per hour squared. Is there a time t from 0 to 24 such that r prime of t equals 0? Well, let me tell you what this is implying here. This is asking about Rolle's theorem. Rolle's theorem says that there would be guaranteed to be a value which the first derivative is equal to 0. Now this would apply if this function is continuous and differentiable, And we are told at the beginning that R is differentiable. On this interval. It says a 24-hour period. And that's an open interval. And that implies that R is continuous. I'll just say this, therefore, R is continuous. Now I did B then A. So it's continuous on the closed interval. I did B then A because we knew B and that told us that A had to be true. Then the last part, we would have to know, is R of 0 equal to R of 24? If you look at our table, R of 0 is 9.6, R of 24 is 9.6. So yes, Rolle's theorem applies. So the question is, it doesn't ask us to find t, it says, is there a time t? So we would say that Rolle's theorem guarantees a value of t in between the endpoints of 0 and 24 such that r prime of t equals 0. So that's one example. We'll do several others in other videos.